Okay, so 2004, pre-response, AP Calculus, question number 6, no calculator. And it gives a differential equation, dy dx equals x squared times quantity y minus 1. And it gives you a set of axes, and they ask you to do a slope field for the given differential equation. So in the answer book will be some sort of slope field thing like this. We're going to fill the one in on the graph here. All right, and I prepared ahead of time some of the equations. So the first thing I hope you notice is I see x squared and I see times y minus 1. So the first thing I did is there's only 3 x values. So I think of it this way. I have -1 as an x value, 0, and 1. And when I plug those in to here, all right, I get 3 different equations. And what I want you to notice right away is no matter what, when x is 0, this equation turns into 0. So I automatically have the slope fields for x equals 0. All 4 of these, are 0. Boom. I am done with that. That easy. The other thing I think you should notice is that the other 2 are the same. So if they're the same, I can simplify this problem. So I know those are the same. I'm going to shrink those down. And I have a table that I made. Because once you know they're the same, all right, so dy dx is the same here. And if I go a little bit bigger, I can plug in. So I can plug into this equation. It doesn't matter if it's plus or minus 1. It's always y minus 1. So I can plug in 0, 1, 2, and 3 for y. If I do this, when y is 0, I get -1. So that's a 45 going downhill for both of those. All right. When y equals 1, there's 0. Okay, so I got 0 and I got 0. Next one, y equals 2 is equal to 1. So again, positive slope, 45-degree angle. Oops, 45-degree angle. That's a little steep. Don't want to give them an excuse to take off a point. All right, smart board's a little off. And finally, the last one's 2, and that has to be steeper. Rise over run of 2. There we go. And there's my slope field. And that is the answer to number 1. All right. So now, number 2. Get that up here. So there's my slope field. While the slope field in part A is drawn only on 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are positive. All right. What you have to catch here is that this is division. All right. It's dividing up the planes. The first thing I think of is where do I have the current one positive? The current one's positive here. All right. You notice everything below here is going to be negative. So, down below, y equals 1. And at y equals 1, it'll be 0. It's asking where it's going to be positive, which is a greater than 1. So what I see is it's anything greater than 1, but it can't be x equals 0. Because you can see on the vertical y-axis, when x equals 0, all the values are 0. So it's asking you, where is the slope field positive? Well, it's positive when y is greater than or equal to 2, or you probably could say y is greater than 1, if you wanted, I suppose, okay? When y is greater than 1, in fact, that would be better if you don't want to do integers. When y is greater than 1 and x is not equal to 0. That would define for all points in the world. All right? And that would be the answer to letter B. So we can, again, strike that down, move it out of the way. All right. And I should be talking points, I suppose. The first one was worth 2 points, that you had all the 0 slopes correct, and all the other slopes. So 1 point was if you had this set for letter A. That's a point. The other points were that you had these 6 right. So 2 points. Letter B is just 1 point. If you couldn't understand the question, it's just 1 point. X does not equal 0, y is greater than 1. That's where all the slopes are positive. Now, C says find the particular solution to y equals f of x to the differential equation for initial condition of f equals 0 equals 3. Guys, This is an integration problem, right? We're going to have to separate and integrate. Now, we talked about this a lot. You have to be prepared to separate and integrate. And I'm going to make this big and put a cover over it so we can talk it through. All right. If I cover it, we can work our way through. First thing you have to do with this differential, computer's a little slow today. All right, is realize you start from this derivative right here that I have shown. And I'm starting right here and I'm working my way down. All right. I have to separate the variables and the dy dx's. And I guarantee this is going to be 2 points. Or 1 point. I'm sorry, this is a point, separating the variables. So y's on one side and the x's are on the other. Just basic algebra. Multiply by dx, divide by y minus 1. And then I need to integrate each side. Get rid of the dy's. And the integration of 1 over y minus 1, it's the absolute value, ln, the natural log, absolute value of y minus 1. The integral of x squared is x cubed plus 3, x cubed over 3, and you have to have plus c. Each antiderivative is a point. 1, 2, and the constant of integration is another point. There are 3 points right on this line. So think about it. At this point, we've separated the variables for a point. You've done 2 antiderivatives and added plus c, and you have 4 points out of the possible 6. The next thing you got to do is realize that to solve for this, you've got to find c. Well, this is a little harder. But you have to remember from pre-calc and our practice that ln is equal to log e. So if I put that in, because a lot of times students get confused here, we have log e of y minus 1 equals x cubed plus c. So we have, right now, a log problem we got to get back. So we recall that we can make the circle. E to the x cubed over 3 plus c power has to equal the absolute value of y minus 1. All right, so we're going to finish this. I'm going to remove the page here. We're going to go 100%. All right, so here we are. And now I'm going to use 2 things. I'm going to use the initial condition, and this is going to get me a point when I put it in. And I know that this is just some constant k. So I can replace this with k. It's just a multiple. It can be some number. So I'm going to find it just as a k value instead of e to the something. It's a non-calculator problem, so I'm really stuck. I can't do it any other way. All right? So I plug in the constant. Y is 3, and x is 0. So this is 1/3 times 0 is 0. So I get e to the 0. And I call the EC just k. So I get 2 equals e to the 0. Well, e to the 0 is 1, so I get k equals 2. And look how cleanly that works. So now I just have to plug in 2 for this. So I have y minus 1 equals 2 times e to the 3rd. Well, move the 1 to the other side, and I have the solution because I want y to be by itself. All right? So y equals 1 plus 2e to the k third. You get a point for using the constant. If you plugged it in here, you get a point. Using the initial, not constant, find the constant, using the initial condition. And finally, you get 1 point for having the equation here. All right, which is the final answer. If you do not have a constant integration, if you do not have plus c, way back up here, the most you can earn is 3 out of 6. And if you did not separate the variables, which I don't know how you can get this problem right without separating the variables, but if we back up, if you did not do this, the note says right on it, you've got to get 0 for 6. All right? So that's how I'm going to score them. I want you to watch the video. We have to get these problems. I consider these some of the easier AT problems. Keep practicing, and you'll get better.